Part B, we're asked to graph y equals 2 to the negative x using transformations. So we first want to identify the parent function here. So if we look at the base, we have a base of 2, and then if we look up in the exponent, we see a negative in front of that x. You can think of the exponent as the quote-unquote grouping symbol that we typically talk about when we're looking at transformations inside or outside the grouping symbol. So even if you want to scroll up to the top here and just make a note, that when you're doing these, graphing these using transformations, you can look at the exponent as the grouping symbol. So the exponent is the quote-unquote grouping symbol. So you're going to look there to see any horizontal changes, and then look outside of that for any vertical changes. Okay, so back to part B here. So y equals 2 to the negative x. So we see that up in the grouping symbol, or the exponent, there's a negative being multiplied. So we know when we multiply the x's by a negative 1, that's going to cause a horizontal reflection about the y-axis. So we'll note our transformation here. We have a horizontal reflection about the y-axis. And then if we look outside the grouping symbol, so anywhere except the exponent, nothing else is happening. It's just the base of 2 raised to that negative x. So there are no vertical changes here, just that horizontal reflection. So we're going to multiply our x values by negative 1 to perform this transformation. So multiply x values of those key points by negative 1. So let's make our table of values. So this is just like we've done in the course so far with transformations. We want to sketch a column here for the parent function 2 to the x, plane 2 to the x, and here's our new function 2 to the negative x. So let's generate the key points. You don't have to memorize them as always, but it's handy if you can generate them quickly. So we use those common points, the negative 1, 0, and positive 1. So if we put a negative 1 in for our x into our parent function, 2 to the negative 1, that's the reciprocal of 2, which would be a half. And then we put the 0 in, 2 to the 0. Excuse me, anything to the 0 is 1. And then if we put in a 1 for the x value, 2 to the first power is 2. So we get 1, 2. And we want to know that horizontal asymptote of that parent function is on the x-axis at y equals 0. So I'll take the x values of all of these ordered pairs and multiply them by negative 1 to perform that horizontal reflection. So the negative 1, 1/2 becomes positive 1, 1/2. The 0, 1 will stay the same. 0 times negative 1 is still 0. And then the 1, 2 will become a negative 1, 2. Now that horizontal asymptote, remember that's a y value or a set of y values. So it's not going to change because we're only changing x values here for this horizontal. So that horizontal asymptote will remain at y equals 0. So we'll go over onto our axes. And I'll sketch our asymptote first on the x-axis, y equals 0. And then we'll just sketch a few units each way. And we know that we don't need to go below the x-axis here because this graph, the parent functions never go below the x-axis, and this one hasn't been shifted down at all or reflected. So we'll just sketch these points. So we want negative 1, 1/2, or sorry, positive 1, 1/2, 0, 1, and then negative 1, 2. So if we connect these, we can see we have a decreasing ramp shape approaching that horizontal asymptote, but never crossing it. So let's label these points. So we've got 1, 1/2, 0, 1, and negative 1, 2. So we can see this is a decreasing ramp shape. Well, that's because the parent function 2 to the x we know would be increasing, but if we reflected about the y-axis, then that's going to become a decreasing ramp shape. So just make sure when you do these transformations, as always, that we show this corresponding table of values. So I'm grading this, and then the sketch over here with your 3 key points and that asymptote labeled with the correct ramp shape.